Hi everybody. So I'm making another video today because I want to go over the review material for the test for Unit 5. So we're going to do all of these. We're going to do all the answers to these problems. And ideally you will have already tried these, and then you can compare your work and see how you did. So that's the plan. Alright, so let's get right to it. Find the missing sides of each triangle. Leave your answers in the simplest radical form. So I've not done these yet, so if I make a mistake, let me know, which is very possible. So you'll notice we have 2 of the 3 sides, and it's a right triangle, which means we can use the Pythagorean Theorem, which is exactly what we're going to do. We know this is the hypotenuse because it's opposite the 90-degree angle. The a and b are interchangeable. So we're going to say, all right, a squared plus b squared equals c squared. And our a is 5, so 5 squared plus 14 squared equals x squared. 5 squared is 25. 14 squared, is that 196? I don't remember. Man, I don't know 14 squared. I know 13 is 169. Okay, I'll double check that. Times 14. 196. I was right. I didn't trust myself there. Oh well. And then add that to 25. And this will be 221. Okay, so you'll notice it says leave in the simplest radical form, which we're going to see if we can simplify that. So x is going to equal radical 221. Can we simplify that? I don't think we can. I'll tell you why. I'll run you through a few tricks here. Is it divisible by 2? No, because it does not end in an even number. Is it divisible by 3? No, because the digits do not add up to a number divisible by 3. 2 plus 2 plus 1 is 5. That's not divisible by 3, so therefore 221 is not divisible by 3. Is it divisible by 4? No, because it's not divisible by 2. It has to be divisible by 2 in order to be divisible by 4. Is it divisible by 5? No, because it's not ending in 0 or 5. Is it divisible by 6? No, because it's not divisible by 2 or 3. It has to be divisible by both of them. Is it divisible by 7? No, it's not. There is a trick for 7, but I'm not telling you that because it'll take forever. Is it divisible by 8? No, because it's not divisible by both 2 and 4. Is it divisible by 9? I don't think so. No, it's not, because it's not divisible by 3. And it's not divisible by 10. Is it divisible by anything else? I don't think so. Pretty sure it's prime. If I'm wrong, let me know. Maybe it is. I'm pretty sure it's prime. 99.9% sure. But I've been wrong before. All right, here we go. So here's another example of Pythagorean Theorem. So yeah, we have our hypotenuse, we have our legs. So a squared plus b squared equals c squared. X squared plus radical 82 squared equals 12 squared. X squared, radical 82 squared is going to be 82, and 12 squared is 144. So now we're going to solve for x. So we're going to subtract 82 from both sides. We're going to get 62. So x squared is 62. We're going to square root both sides. X will be equal to radical 62. Can we simplify that? Let's check. 2 and 31, that's prime. Nope, we can't simplify that. So radical 62, those are the first 2 problems. All right, next one. Is this a right triangle? Let's find out. What you're going to do is use Pythagorean Theorem and see if it's true or not. If the Pythagorean Theorem is true, then yes, it is a right triangle. If it's not true, then no, it's not a right triangle. It's that simple. So what you need to do, though, first is identify the longest side. It's definitely not 8. It's either one of these 2. Radical 105 is slightly larger than radical 100, which is 10, because square root of 100 is 10, so this is clearly larger than that, so this is our C. So C, A, and B. So A squared plus B squared hopefully equals C squared. We're going to find out. A squared, so 105 radical squared plus 8 squared equals 16 squared. So this will be 105. This is 64. And then 16 times 16 is going to be 256. And this is going to equal 169. And these 2 do not equal each other, therefore it is not a right triangle. Okay? Because the Pythagorean Theorem did not work. Let's try it over here. Again, this will be larger than radical 110 because this number would be in between 10 and 11, which that's definitely larger than. This is actually larger than that. All right, so C, A, and B. A and B, again, are interchangeable. The only one that really matters is C. So A squared plus B squared equals C squared. 12 squared plus radical 110 squared equals 16 squared. 144 plus 110 equals 256. This is going to be 254, I think. Yep. And it's not 256, so again, this is not a right triangle. Oh, this is much closer. Right triangle. Okay. State if each triangle is acute, obtuse, or right. So we're going to do something. We're going to basically do the same thing we did over here, but instead of it being equal to or not, we have to know which one is actually greater or not. It'll make sense to do it. All right. So this is 4. This is 12. This is radical 130. We know this is larger than that because this would be radical 144 to be as large as that. This is square root of 144 is 12. So therefore, this is smaller than 12. This is our C, A, and B. So a squared plus b squared equals c squared. Our a is going to be radical 130 squared plus 4 squared equals 12 squared. So 130 plus 16 equals 144. Oh, not equals, sorry. Shouldn't have an equal there. So 146, and this is 144. Okay, so here's the deal. The a squared plus b squared is larger. Therefore, it's acute. I'm going to write a little note here to make it easier for you. So if a squared, this is from your notes in 5-1, if a squared plus b squared is larger than c squared, it's acute. Okay. If a squared plus b squared is less than c squared, it's obtuse. Don't forget the e. And then if a squared plus b squared equals c squared, it's a right triangle. So as long as you know these things, you can answer these questions. Okay. All right, number 6. This is going to be our C. This is our A. This is our B. So a squared plus b squared equals c squared. 9 squared plus 2 radical 10 squared equals 11 squared. So 81 plus, I want to do this over here so you can see how I did this. So 2 radical 10 squared would be 2 radical 10 times 2 radical 10. So 2 times 2 is 4. Radical 10 times radical 10 is 10, and that's 40. So 40 equals 121. So that is 121. So guess what? It's a right triangle. I should have circled that before. Okay. So this is really how you do those. This part here. All right. Let's see here. Oh, we got some special right triangles. Yeah, buddy. Here we are. All right. So we get some 45, 45, 90s, and we have some 30, 60, 90s. So remember, special right triangles. 45, 45, 90. Let's do those first. We have x, x, and x radical 2. Okay? You take the length of the side, multiply by radical 2, and that'll give you the hypotenuse with all isosceles right triangles. Yeah. So let's cross out these variables because they're confusing. So 45, 45, 90. They give us the hypotenuse. So this is x radical 2. We're looking for x, which is these over here. So we can just set this equal to x radical 2. So 10 radical 2. Actually, let me split these up here so we have, it's not as confusing to me. There we go. Equals x radical 2. Let's solve for x. We're going to divide both sides by radical 2. And lo and behold, x is equal to 10. Alright, so 10 here and 10 here. Okay, actually I'll do the odds first. I'll go down. And no, we'll go in order. We're going to go in order. Never mind. So 45, 45, 90. So let's cross these out. So this is x, this is x, this is x radical 2. We know these are the same, so this has to be radical 2. And this is this times radical 2, so x radical 2. Our x is radical 2 times radical 2. Radical 2 times radical 2 is just 2. So there we go. Let's look at number 9. 45 degrees, get rid of these. So this is x, this is x, this is x radical 2. Again, they give us the x, so we just rewrite it over here. It's the same thing, 7 radical 2 over 2. And here, x radical 2, so our x value is this. So 7 radical 2 over 2 times this radical 2. These radical 2's will become 2. So 7 times 2 over 2. These 2's will cancel. We have 7. Okay, or you get 14 over 2 and you get 7 anyway, but it's just faster that way. Okay, let's get rid of these variables. 45 degrees. Okay, x, x, and x radical 2. Again, they give us x, which makes our life a lot easier. So radical 6. And we're going to multiply that by radical 2 because this is x radical. What is that? It's not a 2. Jeez, what am I writing? X radical 2. Or x is radical 6 times radical 2. Let's It's going to be radical 12. We can simplify that because 2 times 6 and then 2 times 3. So we're going to rewrite that as 2 times 2 times 3. We have two 2's, which means you cross it out, and 2 on the outside, so 2 radical 3. And that is our hypotenuse there. Okay. Number 11. So 45 degrees, get rid of these variables. Okay. X, and x radical 2. So we have the hypotenuse. We're going to say x radical 2 is equal to 8. We're solving for x. We're trying to get the x's, right? So divide both sides by radical 2 because we want to get x by itself. And this is the kind of problem that gave people a hard time earlier in the unit. 8 over radical 2. We can't have a radical in our denominator, so we're going to multiply the top and bottom by radical 2. We can do that because this is actually equal to 1. We're not changing any value here. So x equals 8 radical 2 over 2, because these become 2. This can simplify, so x equals 4 radical 2. And that's what this is, 4 radical 2 and 4 radical 2. Okay, number 12. Again, this is 45 degrees. Let's get rid of these variables. So x, and x radical 2. We're going to solve for x. So x radical 2 equals 2 radical 2. You can see where this is going. Divide by radical 2. And that's going to be x equals 2. So there we go. So 2 there and 2 there. Whew, I need a drink of water. that was a lot. 1 second. Okay. All right, so let's go now to 30, 60, 90s. All right. 30, 60, 90s, we're going to have, outside the example over here, I guess. So you're going to have a 90-degree angle, you're going to have a 30-degree angle, and you're going to have a 60-degree angle. So the shorter side will always be the side opposite the 30-degree angle, and that's going to be your x. In this case, I use x. You can use any variable you want, but that's the short side. The hypotenuse will always be double that, and then the longer of the two legs is going to be x radical 3. Okay? So let's take a look at this one. So 60 is here. That means this is 30. I cross out my variables. I establish what I have. So 30, okay, this is the short side, therefore this is x. This is 2x, and this is x radical 3. Life is a lot easier when they give you the short side, although it's best when it's an integer to make it easier for you, but whatever, we'll make it work. So x is radical 2. So 2x will be 2 times radical 2, which is just 2 radical 2. So 2x is going to be 2 radical 2. Okay. Now over here, x radical 3. So, okay, well, x radical 3 is going to be radical 2 times radical 3, which is radical 6. And that cannot be simplified. So radical 6. And that's it. Okay, let's check out the back. So we got a few more of these. Oh, okay, we're moving right along. So number 14. I'm going to write that formula over here so I can refer to it. Actually, hold on. It's just nice having it in front of you. So 30, and this is 60. X, 2x, and x radical 3. Okay. So here, first let's get rid of these variables. They drive me crazy. There you go. All right, so 30. They give us, so 30, this is x. This is 2x. This is x radical 3. So they give us 2x. So we're going to solve for x. X is going to be, oh, interesting. 2x equals, actually, let's split these up too. Hold on a second. There we go. Okay. So 2x equals 7. We're going to divide by 2. And x will be 7 over 2. So this is 7 over 2. I wrote that really crappy. Hold on. 7 over 2. It's a little easy to read that. Not really, but okay. I feel better now. And then this is times radical 3. So x radical 3, our x value is 7 over 2. Times radical 3, so it's just 7 radical 3 over 2. And that's it. It's not that bad. 7 radical 3 over 2. That's that. Okay, let's try this one. Well, look at that. This looks awfully familiar to me. What might have happened here? So this is 30 degrees, this is x radical 3, and this is 2x. This looks awfully familiar. Is it the same triangle? It sure looks like it. All right, so x radical 3 is equal to 7 radical 3 over 2. We're going to divide both sides by radical 3 to get x by itself. So put that in the denominator. Those cancel. Yeah, it's definitely the same. It is the exact same triangle. 7 over 2. And this is going to be 7. Yep, these are actually the exact same triangle. It's kind of funny. Okay, let's look at the next one. We got, let's get rid of these variables. This is 30, so our short side is going to be here. This is 2x, and this is x radical 3. So they give us the 2x. So 2x equals 2. We're going to divide both sides by 2 to get x by itself. X will be equal to 1. So x is 1. And then x radical 3 is equal to 1 times radical 3, which is just radical 3. Therefore, this is radical 3. That's it. Okay, next one. We got, cross these out. This is 30 degrees. So this is x radical 3, and this is 2x. See, this is when it's nice, and they give you an integer for your short side. It makes life really easy for you. Watch. So 2x is going to be 2x is 2 times 3, which is 6. So this is 6 here. And then x radical 3, or x value is 3, so 3 radical 3, and that's that. So 3 radical 3. Okay, so we're actually doing a lot of algebra here. If you notice, we're solving for variables and plugging things in and evaluating. There's a lot of algebra going on. Okay, so 30 degrees here, cross these variables out. So this is going to be our x. This is our x radical 3, and this is our 2x. This is going to be a little messy. Here we go. So 2x equals 5 radical 6. Divide both sides by 2. So x is going to be this really ugly looking number here. 5 radical 6 over 2. We're going to put that right here. 5 radical 6 over 2. Okay, that's what that is. Now I have to multiply that by radical 3. Oh my. Okay. So x radical 3. So 5 radical 6 over 2 times radical 3. So radical 6 times radical 3 is radical 18. Are we done? No, because we can actually simplify this. Let's do that over here. So radical 18, let's see, 2 and 9, and then 3 and 3. So you'll notice we have a pair of numbers we can get out of there. So radical 18 is actually 3 times 3 times 2 in the radical. Circle those, cross them out, 3 radical 2. 3 radical 2. So that's going to take the place of the radical 18. Okay, so we already have a 5 on the outside, and then we have 3 that's now outside, and we have 2 left over inside. There we go. 5 times 3 is 15. So 15 radical 2 over 2. Yeah, that's an ugly number. I'm not going to lie to you. That's an ugly number. So 15 radical 2 over 2. Okay. All right, we made it through the special right triangles, guys. Take a deep breath. Huzzah. Okay, now we're going to do trigonometry. So let's write our function acronym here. SOHCAHTOA. I'm switching to blue because I just feel like using it. Why not? All right, so sine of x. So here's our theta. This is our opposite. This is our adjacent. This is our hypotenuse. I'll remind you, sine of theta would be sine is opposite over hypotenuse. So sine of theta is opposite over hypotenuse. So sine of x, in this case, would be opposite is 36. Hypotenuse is 45. Can we simplify that? Yes, they're both divisible by 9. So 4/5. And that's that. Okay, sine of a. So another sine function. So this is opposite. This is adjacent. And this is hypotenuse. So sine of theta is opposite over hypotenuse. So sine of a is 6 over 10. They're both divisible by 2, so that's 3/5. Okay. And we have 2 more. So again, I'm going to write SOHCAHTOA here. There we go. And if you need more on these, I just posted a video that was all about the homework from that section. So if you need more help with that, definitely check that out. Alright, so sine c, this is theta here, so that means this is opposite, this is hypotenuse, and this is adjacent. Okay, so, excuse me, sine of theta is going to be opposite over hypotenuse. Sine of c, in this case, would be 10 is our opposite, hypotenuse is 26. So 10 over 26. They're both divisible by 2, so 5 over 13. And that's our trigonometric ratio. Cosine of z, so there's our theta. Our opposite is here, our adjacent is here, and our hypotenuse is here. Okay. So cosine of theta equals, again, cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So cosine of z is 30 over 34. Those are both divisible by 2, so 15 over 17. Okay, all right. We're going to need our trig tables for the next 4 problems, so make sure you have this handy. Okay, so round to the nearest degree. Okay, all right. So here's our theta. This is our opposite. This is our hypotenuse, and opposite hypotenuse is going to be our sine function. So sine of theta equals opposite over hypotenuse. Sine of theta equals 29 over 59. I'm going to divide that off screen. So 29 over 59. And we're going to go with 4 place values because of the trig table. So 0.4915. There's a 2 there, so it stays as that. So sine of theta. So now we're going to look at our trig table to see which number this is closest to. So sine column is the first column, 4915. 49. Okay, so it's in between these two here. It's in between 29 and 30 degrees here. So 29, sine value for that is going to be 0.4848. So let's subtract and see how close it is to that. 4915. And again, I'm going to do this off screen because I'm going to be a little lazy. 4915 minus 0.4848. So it's 67 10,000ths. It's pretty darn close. Okay. And then 30 degrees. I believe this is 0.5. Yeah, it's 0.5. Yeah, of course it is. What am I thinking? 0.5000 and subtract our value that we found. 4915. Should be 85 10,000ths if my math serves. 0.5 subtracted 0.4915. Yeah, okay, my math actually held. Good for me. Okay, so they're pretty close to each other, but it's going to be slightly closer to this. So 29 degrees is the closer value. Okay, let's try this one. So theta is here. This is opposite. This is hypotenuse. Opposite hypotenuse is going to be our sine function. So sine of theta equals opposite over hypotenuse. And sine of theta is going to equal 24 over 38. Let's see what that is. 24 over 38 is going to be, so sine of theta is going to be 0.631. Now this is a 5, but there's a 7 to the right of it, so I'm going to round that to 6. Okay, for our place values. I don't think it'll matter, but we have to do that anyway. So let's find out where this is in the sine column. Again, that's our first column. So 6316. So 63 is greater than this, so it's between 30. Oh, I'm off screen. Sorry. So it's going to be in between 39 and 40 degrees because it's in between these two values. Okay. So yeah. So for 39 degrees, value is 6293. This is greater, so we're going to subtract from that 6316. Let's see how close it is. So 0.6316 minus 0.6293. So 23 10,000ths. Pretty close. Pretty close. Then 40 degrees is 0.6428. 0.6316. Let's see what we get there. 0.6428 minus 0.6316. So that's 0.0112. Alright, so this is significantly closer. So 39 degrees. Okay, yeah, those are involved. Those are a little involved. Alright, here we go. Find the missing side. So, this is going to just involve some algebra here. So here's our theta. That means this is our adjacent, and this is our hypotenuse. Then it's the cosine function. So cosine of theta equals adjacent over hypotenuse. Cosine of 58 degrees equals 20 over x. And I'm going to look for cosine of 58 degrees in my column here. So 58 degrees is here. Cosine is my second value, so this is the number we're going to use, 0.5299. Okay. So 0.5299 equals 20 over x. And now we just solve this algebraically. So we're going to multiply both sides. A little bit of red here. Multiply by x. We're going to have 0.5299x equals 20. And then divide both sides by this ugly number here. Oh my, that is ugly, isn't it? 299. Oh, I forgot the 2. Cross these out. I'm off screen. Doesn't help us. There we go. So 20 divided by 0.5299. Alright, so round to the nearest tenth. Alright, so we have x equals 37.74. So this is to stay at 7. So x equals 37.7 degrees. So let's try this. Last one. We made it, guys. We're almost there. Here we go. So theta, this is going to be our hypotenuse. This is going to be our opposite. So opposite over hypotenuse is going to be a sine function. Sine of theta equals opposite over hypotenuse. Okay, so sine of 52 degrees equals x over 16. So we're going to find 52 degrees in the trig table here. Right, and it's a sine function. So 52 degrees, it's going to be this value here, 7880. Okay. So 0.7880 equals x over 16. We're simply going to multiply both sides by 16, and that'll give us our answer here. Oh, got too excited there. 16 times 0.7880. So we get x equals 12.608. This is going to stay at 6 because to round, this is a 0, so 12.6, 12 and 6 tenths, 12.6 degrees. On the off screen. That doesn't help. There we go. Okay. Alright, so that was a lot. We did all of it. This is probably the longest video I've ever recorded for the class. I apologize. If you stick through the whole thing, then man, you guys I'm impressed. So, hopefully that was helpful. If there are any of these problems you think I made a mistake, let me know. Or if there's any of these problems that you find particularly confusing and I didn't explain them properly, please let me know. The test will be due on Tuesday, so you're going to have like 4 or 5 days to work on it. Okay? Thanks, guys. Appreciate it.